Okay, a while back ago, we had a formula, a general term, a term generator like this, right? And we didn't do this, but I said, hey, you could just find like the 100th term if you wanted to. You could say a sub 100, and then you'd put in 100 for n, and you'd add 4. And we didn't do that. We just found the first 4 terms. But you could do this, right? You would get 304. So if somebody said to you, here's a generator, and I want you to find the 100th term, no problem. You put in 100 for n, and you say, hey, the term is 304, right? Okay, but remember our other sequence, the Fibonacci one? And we had 1, 1, 2, 3, 5, 8, and it kept going. And remember, it was based on the previous terms, like 5 plus 8, that got you the next term, 13, right? And then you had to take the 8 and 13 to get the 21. Well, now if I want to find the 100th term, that's going to be kind of hard because I have to find terms 99 and 98. I'd have to know a sub 100 would be a sub 90, well, that's not going to fit. A sub 100 would be a sub 99 plus a sub 98, right? Take the two previous terms to add them. Well, you don't know what these two terms are, right? This is called a recursion formula. So a recursion formula is based on previous terms. Now, we're not going to ask you to do 100 Fibonacci terms, so don't worry about that. They usually keep it fairly small, but it's based on previous terms. So you can't just jump into the middle of the sequence and say, hey, here's term 25. You have to do the ones that lead up to it. Okay. So it says find the first 4 terms. Okay, that's nice. Of the sequence in which, and they tell you the first term. In a recursion formula, they have to start you someplace. They have to at least tell you one term. Okay, now here's what gets tricky is the writing out. So we know the first term, and we're supposed to find the first 4 terms. So we're trying to find a sub 1, a sub 2, a sub 3, and a sub 4. Okay, we know a sub 1. A sub 1 is 5. Okay, so got that one. Check. That one's done. Okay. Now, how are we going to find a sub 2? Well, here's the generator right here. It says a sub n equals 3 times a sub n minus 1 plus 2. And I'm trying to find a sub 2 right now. That means my n is 2. So it's 3 times a sub 2 minus 1 plus 2. Well, this is a subscript down here, the 2 minus 1. So what is 2 minus 1? 1. So I have a sub 1 plus 2. But do I know a sub 1? I do know a sub 1. They told me that. So I replace a sub 1 with 5 because up here it said a sub 1 was 5. Okay? So I knew that. Plus 2. Okay, 3 times 5 is 15. 15 plus 2. Okay, is 17. Okay, now I know a sub 2 is 17. Okay, check. Now I want to find a sub 3. Well, how do we find a sub 3? Well, we're going to use this generator right here. We're going to say it's 3 times a sub 3 minus 1 plus 2. But what's 3 minus 1? So it's a sub 3 minus 1. That means a sub 2 plus 2. Now, do you know a sub 2? You do. You just figured it out. It was 17. Okay, now I have to know what 3 times 17 is. I'm pretty sure it's 51, but you have a calculator. You can check that. Okay, 53 then. Now I know a sub 3. Check. Okay, so now I go to a sub 4. A sub 4 is going to be 3 times a sub 4 minus 1 plus 2. So you kind of see the pattern here. So 3 times a sub 3. So I need the previous term, multiply it by 3 and add 2. So it's 3 times 53. Oh, I'll have to figure that out. All right, 3 times 53. Now everybody knows where that 53 came from, right? It was right here, and I'm plugging it in. Okay. 3 times 53 is 159. plus the 2, and I'm getting 161. Okay, I know the first 4 terms then, and that's all they wanted to know. So my first 4 terms are 5. That was the first one. They told me that. Then I got a 17 for the second term. I got a 53 for the third term. And then I got a 161 for the last term. Okay, there's the first 4 terms. So they're pretty fun.